The servo amplifier has 28 connections, 3 fuses, and 6 LEDs, and performs numerous jobs in the controller, including 1. Receiving serial servo data from the access control card of the main board and transforming it into pulse width modulated DC power out to the joints of the robot to execute motion instructions. 2. Supplying 90 volts DC to release the brakes of the motors. 3. Communicating numerous handshakes with the e-stop board during pre-charge of the DC link circuit to ensure safe operation of the robot. 4. Sending excess energy to thermally monitored discharge resistors and monitoring the thermal condition of the main transformer. The servo amplifier has 3 levels of activity. Level 3, the control tower, receives and processes data. Level 2, the powerhouse, includes the rectifier and DC link circuit. It also sends and receives encoder data, robot I/O, and other information. Level 1 is the muscle. The IGBTs send pulse width modulated power out to the motors at up to 19,000 times per second. Pretty impressive. Imagine a day with no servo amplifier. The power supply, main board, e-stop board, teach pendant, 200 volt AC fans, and 24 volt DC fans would still power up. No part of the on-off circuit runs through the servo amplifier. The manipulator, however, would be paralyzed. There would also be a litany of servo, system, and other errors to read and contend with. If the servo amplifier is actually going to do something, putting it back in the cabinet and connecting it into the system is a high priority. Let's look at the connections. CAX2A and CAX2B. CAX2A is an e-stop presence signal that runs out of a 6-axis amplifier to CAX2B of an auxiliary servo amplifier. CAX2A is always an output and CAX2B is always an input when daisy chaining servo amplifiers together. CRF8. There are 4 types of signals running in and out of CRF8. All of these signals come together and run through RP1 cable out to the base of the robot. Number 1, pulse coder signals from the encoders to verify the robot's current position. 2, robot I/O designed for use of robot end effectors. 3, power for the SRAM memory of the encoders when the controller is turned on. 4, hand-broken and robot over travel are both signals designed to stop the robot by generating a servo error when continuity is broken in either of the 2 circuits. Those same servo errors can occur when fuse FS2 on the servo amplifier blows. The robot I/O, or RIO, runs in and out from and to the EE connection on the front of J3 on most robots. Discharge resistors. On most robots, CRR63A and B run out to 2 discharge resistors fastened together in the rear compartment of an A-style cabinet. These connections carry excess energy generated by the servo amplifier to be dissipated as heat. The discharge resistors have a thermal monitoring system that sends and returns from the connection CRMA91 on the servo amplifier. If excessive heat is present in the system, a thermal switch opens and an over-temperature error is generated. COP10A and B. COP10A is always an output and COP10B is always an input for 2 strands of fiber optic cable called FSSB, or FANUC serial speed bus. One strand sends commands, the other receives confirmation from the encoders. The robot's access control card is both the source of motion command data and motion confirmation data for the robot system. Its interface connection is COP10A on the main board. The COP10A output runs into COP10B of the primary servo amplifier. When there is an auxiliary servo amplifier, COP10A of the primary servo amplifier daisy chains into COP10B of the auxiliary amplifier. This pattern would continue on for additional amplifiers as well. Motor power connections C and J1 through 6 and brake power CRR88 come together as the motor cable RM1 and run out of the bottom of the controller to the base of the robot. RM1 interfaces with the internal cabling of the robot and once again splits off into 6 separate motor connections. The CRR88 brake connections also split off into 6 separate brake connections. CRR30iA and B. FANUC makes multiple versions of servo amplifiers to accommodate a wide array of robots with a wide variety of load capacities. On many robots, the current capacity can be carried on the 3 wires of connection CRR30iA. On robots with large reach and large load capacity where more power is required, 2 motor cables deliver the additionally required current. On these large capacity robots, the current is distributed across 6 wires and both CRR38A and B are required. CRRA12. CRRA12 is one of several connections that creates handshakes between the servo amplifier and the e-stop board. This handshake monitors the status and start of the pre-charge circuit. Servo amplifier fuses. FS1 is part of a 24V circuit and is used for control power of the servo amplifier. In this part of the circuit, 24V is split and lowered to 5 volts and 3.3 volts. When those voltages are present, 2 LEDs light up. When this fuse fails, a Servo 57 FSSB disconnect error is generated and no LEDs on the servo amplifier light up. FS3 is part of the 24V circuit and is used to monitor the thermal switch in the discharge resistor. The 24V runs through a thermal switch, and if the temperature is beyond the threshold, the switch opens, continuity is lost, and a discharge alarm is generated. FS2 is also part of the 24V circuit and is used for hand-broken, over-travel, robot I/O, and auxiliary access power. If FS2 blows, errors related to those items are indicated along with a fuse blown error. Servo amplifier LEDs. There are 6 LEDs on the servo amplifier. They are servo alarm, indicating a servo alarm is present. Servo emergency, indicating an e-stop is present. Drives ready, indicating that the DC link circuit is charged and it's ready to rock. Open, indicating communication between the mainboard and the servo amplifier. PS5, indicating that 5 volts is present, and P3.3, indicating that 3.3 volts is present. For robot nerds and production managers alike, a day without a servo amplifier? Why, that would be like a day without sunshine.